So guys, this is a problem number 5. This is a 2D equilibrium problem. Then it says the beam has a weight of 700 pounds. Determine the shortest cable ABC that can be used to lift if the maximum force of the cable can sustain 1,500 pounds. So the maximum force that it can sustain is 1,500 pounds, okay? And the weight is 700 pounds. So first thing what we're gonna do is we're gonna draw a free body diagram. 700 pounds. In this case, the weight is outward because this thing is holding it. All right, so it has to be going upward. This is FAB. This is FBC. And this data right here is just corresponding to the data right here. They're the same thing. Okay, so first thing what we're gonna do is we're gonna do our free body diagram. I mean not that summation of the forces. So summation of forces in the X first. This will be FAB, make it FAB cosine theta. Make it FAB sine theta. This one is FBC cosine theta. FBC, make it FABC cosine theta. Not cosine, sine theta. And summation force in X will be negative FAB cosine theta plus FBC cosine theta equal to 0. And then just bring this one over. We know that FAB will be equal to FBC. All right, and then let's do summation of force in the Y. It will be negative FAB sine theta minus FBC sine theta plus 700 equal to 0. And then what we can do is we can either replace FAB with FBC or FBC with FAB because we know that they're going to be equal to each other. So I'm going to do in this case that I'm going to replace FBC with FAB. Okay, and then if I rearrange the equation and move them right here, I'm going to get 700 equal to 2 FAB sine theta. And then I know that the maximum that this can hold will be 1,500 pounds. So I know that my FAB or FBC will be equal to 1,500 pounds. So 700 to 1,500 sine theta. So my theta equal to sine inverse of 700 divided by 3,000. My theta will be equal to 13.5. Okay, so my theta is 13.5. All right, and let me draw the free body diagram again right here. It's going to be like that. 15.5, 13.5. Okay, so you know what? Yeah. Okay, this is fine. This is fine. Okay, so it asks us the shortest distance that cable ABC can be lifted. Okay, shortest distance. So how much? So it asks to find how much. What's the value for this line, and this line is. Okay, so what we can do is that we know that this line right here is going to be 10 feet, right? This will be equal to 10 feet. Okay, and then we actually have two triangles right here. So we have two separate triangles that we can do analysis, but we know that at the end they're going to be equal to each other. Okay, so I'm going to draw the triangle out. So let's do the triangle on the left first. Okay. So if this is 13.5 degree, I know that this will be 5 feet, and I'm trying to find what this is right here, and let's just call this LAB, and then What we can do is I know this will be cosine of the angle is 13.5 equal to, what's cosine? Cosine equals adjacent divided by hypotenuse, right? So it would be 5 divided by LAB. And then I got LAB equal to 5 over cosine 13.5. Okay. And then the same thing for LBC. LBC will also be equal to 5 cosine 13.5 because they're the same triangle. Okay. All right. So I can do is that I can let me scale down this first because I don't have any more room to write. Okay, from this step on, we have to add LAB and LBC together because the whole triangle is LABC. Okay, so LAB plus LBC. Then we can bring this over 13.5, and then they'll be equal to, because the total distance will be 10 feet. Okay, all right. And then what we can do right here, just bring this one down. So LABC equals 10 over cosine 13.5. All right, and LABC will be equal to 10.3 feet. Okay, so this is our final answer. All right, guys, so problem number 6 is also a 2D equilibrium problem. It says the block has a mass of 5 kilonewton and rests on a smooth plane. Unstretched length of the spring will be closest to. So we're trying to find the unstretched length. Okay, so we know that L, let's call L stretch, is equal to L unstretched plus, let's call this S, and yeah, let's just call this S. S is the distance that is being stretched. Okay, so what's given? Mass is given, but we don't want mass, we want weight. What are we gonna do? Weight equals mass times the gravity equals 5 times 9.81, which is 49.05. And then this is the weight of the block right here, which is 49.05. Then we can draw our triangle for that. Okay, and this will be 45 degrees right here. Okay, and this will be cosine, this will be sine. All right, and what we're gonna do right here is just do our summation of the forces equation. But first I have to make a triangle right here. This is 0.4, 0.3, so this will be 0.5, this one right here. This is the distance that's being stretched. How I know this distance being stretched? Because the question asked what's the unstretched length. Okay, so if the question asks what's the unstretched length, then this has to be the stretched length. Okay, summation of the forces in the x direction equals 0. Okay, and then I forgot to tell you guys the axis. So this will be positive y, this will be positive x. Okay. Okay, and then let's go. Summation of the force in the x direction, it'll be 49.05, but it's negative. Why? Because it's going downward. And then cosine of 45. And then plus, and this is a force right here also. Let's call it FSP, which is F spring. And F spring is going upward. And it's a horizontal value of 0.4 divided by 0.5 equal to 0. And then what we can do right now is that we can actually replace FSP with KS, because F equal to spring constant multiplied by the distance being stretched. I can just replace this with KS. Okay. Then if I put in the calculator, I got negative 34.68 plus I know my K is 200 because right here it's 200. S 0.4, 0.5 equals 0. And then what I can do right now is just distribute this to 200. 34.68 plus 160 S equals 0. And then S is equal to 34.68 because bring this 34.68 over, it become a positive over 160. I got my S equals to 0.2167. And so I found my S, and then I know the L stretch. The L unstretch plus S, 2 pi L unstretch. So just bring the S over. So L unstretch equal to L stretched, which is 0.5 minus the S, as is 0.2167, and L unstretched will be equal to 0.2833 meter. Okay, so guys, this is the final answer.